Okay. All right. So let's go over a couple rules. I may add to these because I may forget them. I may forgot some. So far, I can only remember two things that I can think of. First off, and this is usually the hardest one for you guys. You have to show all steps. Basically, these are proofs. So since they're proofs, you can't skip steps. You have to show them. Because you can't, skip from all the way up here to all the way down here, expecting me to believe that you know how you got from, step A to step E.
But it happened, though. So if you take a random guess, you get it?
Yeah, you can't expect me to believe that you knew that.
I did that one time.
That you got from tangent to some random thing all the way down here because you knew that you had to eventually get to it, but you didn't know how to get to it. You have to show that you actually knew how to get to it. So this is usually the hardest thing right here. Okay, second thing is we're working with equal signs, but you cannot use your properties of equalities with proofs. So, no moving between sides. That's another thing that people have problems with. They see that they have, I have a cosine on both sides. Let me just divide both sides by cosine. You can't do that. Or I have a sine on this side. I really wish I had a sine on that side, so let me just subtract sine from both sides. You can't do that. No moving between sides. It does not matter which side you work with. You can work with whichever side you want to. You just cannot move between sides. You cannot take something from one side and move it to the other side. You cannot multiply both sides by something. You're working with this just like your simplification problems. Just as you're working with it, you have to ignore that there's an equal sign. You're proving that there's an equal sign. So, since you're proving there's an equal sign, at this point, it doesn't exist. Yes. So, the whole point of this is you are proving this. Since you are proving that equal sign exists, you cannot use your properties of equality. Because you don't know that equal sign actually exists yet. So once you start using your properties of equality, that means you're assuming that equal sign exists. You don't know that. Okay, so if I think of anything else as we go, I'll put them on there. But those are the two big ones that I know that people have the biggest problem with. Okay, beyond that, it's just like 5-1. So we just take this, and we need to simplify that. We just know that this is going to simplify, and it's going to equal 1 now. So we take this side, and we just start simplifying it. You can do whatever you want to it. So what do you want to do? You want to distribute it? Okay. Okay, now what? Cancel out cotangent. How? Put parentheses around what? I can't just put, I can put parentheses around it, but that's not going to do anything. Okay, so we're stuck. If we're stuck, what's one of the things we can always do? No, don't start over. Change them all into what?
Oh yeah,
Sine and cosine. Yeah. Okay, so we can cancel this. Again, don't do more than one step at a time, so once I cancel that, I need to rewrite it. Okay, I have like denominator, so I could go ahead and subtract my fraction, right? Okay, so this, by your Pythagorean, that's equal to sine squared y. Okay, since we're doing a proof, we have to actually show both sides are equal, so we need to show sine squared y over sine squared y is 1, so 1 equals 1. So, we finished our proof. Yeah, if you're stuck on this step right here, going from there to there, what we did is our Pythagorean is this. All we did was rearrange it by subtracting the cosine squared to the other side. Again, if you don't like doing that, that's fine. What does 1 equal? Well, 1 equals sine squared y plus cosine squared y, so you could substitute that in, cancel out your cosine squared y's, you get the same exact thing. We talked about that yesterday. So, that's 5-2. I'm going to go through some other examples with you, but that's the only difference between 5-1 and 5-2, is that you know whenever you're simplifying where you're heading to. We know that whenever we get done with this, we should be equal to 1. And the other difference is we have to show all our steps. All right, am I okay to move on? I have 4 examples. Okay, I wanted to do this one to show you that you could work with both sides a little bit. Okay, first thing I notice is that both sides definitely have cosines, right? So what I want to do is I want to eliminate that as an issue. So what I'm going to do is I'm going to take the cosine out of this side. And the cosine out of this side. I cannot divide it off. It's still part of my problem. But I can pull it out to make my problem a little bit simpler. Then all I'm doing is I'm working with whatever's inside the parentheses. Okay, which side do you want to work with? Usually you want to take the side that looks the most complicated and try to make it simpler. So which side looks most complicated? The left side? Okay, so left side. Okay, so what do you want to do with that? Well, notice this side only has one fraction, whereas this thing has two things separated by a minus sign. So it'd be good if we got it turned into one fraction.
Why did you take out the cosine in the second one?
Just because they both had it, so it simplifies just to get rid of it.
No, why didn't you take it out of the second one?
What do you mean take it out of the second one?
The denominator?
Because I can't take it out of the denominator. I can only take it out of the numerator.
Oh.
I can't separate it from the denominator because it's connected with a minus sign.
Okay.
So since this has a single fraction, I want to turn this into a single fraction. So I turn 1 into something that I can subtract. Okay, I'm going to do my subtraction. So 1 minus 1, that would disappear.
So why would you take it minus 10x?
Just to match the denominators. Okay, so I'm a little bit closer. Okay, I don't like that negative sign in front because this one doesn't have a negative sign in front. So what I'm going to do is I'm going to absorb it into my denominator. That makes sense to you? Okay, so now what?
Wait, but I think the rule is that if you do something with the denominator, you have to do
This is just a negative 1. This is negative 1 times this.
Yes.
Well, with the negative 1, I can treat that as negative 1 over 1 or 1 over negative 1. And then just multiply. So what I did is I treated this as 1 over negative 1 and multiplied.
Okay. Okay.
Okay, so if we're stuck, what's one thing that we can always try doing? Sines and cosines. Now, before I do that, I'm going to do this because I'm going to be making a whole bunch of fractions, right? So I'm going to do this. Just stick with me. I'll show you why here in just a second. Maybe, because this may not even work. Okay, that doesn't look like that's doing me any good, does it? Yeah, it does. What does this mean?
They cancel out.
This means that I multiply the top by sine and the bottom by cosine, correct? So this means I have sine x over, okay, whenever I multiply the bottom by cosine and I distribute that, what happens to this first fraction? What does that turn into? Minus, I have to distribute, so cosine times 1. Which is equal to Now this tells me whenever I need to stop. I equaled what I had on the other side.
To the side. Is that what you do?
Yep, so the whole point of this is to make it equal the other side. Where? Here? Okay, so here I took the tangents. I changed them into sines over cosines. Okay, now this is just a fraction times a fraction, right? So you take the numerators and multiply them. And the denominators and multiply them. So this means in the denominator I have cosine times all of this. So that means I'm going to distribute that. So I have cosine of x times sine of x over cosine of x minus 1. I'm going to distribute that. So whenever I take this times this, they cancel out. Now, is that the only way to do it? Nope. Is there easier ways? Probably. Yeah.
Why did one transform into cosine of x?
Because you have to distribute. I have to take this and distribute it.
Okay, right.
So I can't just take it times the first one and make it disappear. So that's the other thing 5.2 is going to introduce to you, is it's going to introduce you to harder problems. So I love these problems because these problems tend to freak you guys out. Not only do you have sines and cosines, but what else do you have? X's and Y's. So we cannot combine cosines of x's, and whenever we get to our Pythagoreans, which we will get to in this, we cannot combine cosine squareds of x's with sine squareds of y's. No, these harder problems won't be on the quiz tomorrow. We'll get to the harder problems later. We will get to them on the quizzes and the tests. No, the ones tomorrow will be easier ones. There'll be problems from 5.1 in this form. Okay, so where should we start? What? Because that's what we should get to in the end. Okay, we have two fractions. What do we always do when we have two fractions? Get like denominators and add them together. So this fraction, remember, we have to write down every step. We can't just magically make it happen. So what does this fraction need to be multiplied by? Okay, what does this one need to be multiplied by? Okay, now this is going to take a little bit of foiling whenever we do this. Your denominator is just going to be the same thing, right? Okay, now, just to simplify, because I get tired of writing. I don't like writing. I'm just going to say that this here, this is equal to squiggle. Ah, I defined it. Squiggle is equal to that.
So you're cool. No, I mean, like, can we do that with quiz?
What? Go ahead.
When you look like cosine of x times cosine x,
No, cosine squared x.
What? So can we do that on the quiz? Like,
Yeah, I don't care.
I'm saying I don't want to write
Okay, now notice up here, this is actually difference of squares. So I could FOIL it and multiply it all out, but it's just difference of squares. So this is just going to end up being cosine squared x minus cosine squared y.
but we have to do the word.
Difference of squares is the formula. I can use it.
Oh, well, it's really
So this is also difference of squares over here. That'd be like saying that every time you have Pythagorean, you have to prove the Pythagorean again. Okay, so I go to add these together. Wherever I add them together, I'm going to rearrange them a little bit. So I'm going to rearrange this so my x's are together and my y's are together. So I have sine squared x plus cosine squared x minus sine squared y minus cosine squared y. Now, notice that both of these have a negative sign on them, right? So I could rewrite this. I could put this in parentheses and put a plus sign there. That's the same thing, correct? If I pull out that negative sign and put it in the parentheses, I could redistribute that negative sign and still get the same thing that I had there. Okay, what's sine squared x plus cosine squared x? 1. What's sine squared y plus cosine squared y? Okay, what's 1 minus 1? What's 0 over squiggle?
That looks so weird.
Really, if you get an upper level math person, they would be very angry with you for using a squiggle. They would want you to set it equal to, an actual variable like z. I don't like letters. I like squiggles. I mean, we could set it equal to happy face, but
like brick
because my squiggle doesn't actually look like the same squiggle each time, so they would get pissy with that.
Different squiggle.
Yeah.
Okay.
So, who says that this squiggle is actually equal to this original squiggle? Because they don't look like the same squiggle.
No.
But the reason I did that is because the denominator never actually mattered. And if it did end up mattering, I could always take the squiggle out and put the denominator back in at the end.
Okay. So what you did here is you just did the Pythagorean twice?
Yep. This and this are both Pythagorean, so they both turned into 1. 1 minus 1 is 0, so I got 0. So whenever you have these with x's and y's, it's okay. It will all work out to where you'll be able to sort them out and keep the x's with the x's and the y's with the y's, and everything will work out. If they tell you it will work out, it will work out.
always.
They said it equals 0, so it will equal 0. You just have to prove that equals 0. You just have to go through the work. Okay, one more. Okay, I want to do this one just to prove to you that you don't always have to work on the left-hand side. We can work on the right-hand side. We can work on the left-hand side. We could work on the left-hand side and just do some factoring and get this to work out, but instead I'm going to work on the right-hand side. So the right-hand side says that I need some, or the left-hand side says I need some sines, and I should only have one cosine left. So what I'm going to do is I'm going to take this left-hand side, and I'm going to pull out one cosine, because that's all I need. And then I'm going to take that cosine to the fourth and change it into sines. How can I change cosines into sines? Nah. There, I'll put a dot for you. Means multiplication. Okay, so how can I change cosine into sine?
First, put cosine forward into cosine squared back. Cosine squared back.
Okay. Yes, that's my next step. Cosine squared of x times cosine squared of x. Okay, now what? How do I change cosine squared of x into sine squared of x?
Use sine squared back plus cosine squared back.
Okay, so Pythagorean says cosine squared of x plus sine squared of x equals 1. So that means cosine squared of x would equal this because of the Pythagorean, correct? So I just needed to break it up to get to cosine squared of x's so I could use my Pythagorean. So the left-hand side said I needed sine squared, or sines, so I needed somehow to change my cosines into sines using Pythagorean. Pythagorean says that cosine squared of x plus sine squared of x equals 1. So I just took and rearranged it so that cosine squared of x equals 1 minus sine squared of x. And then I did my substitution. So I'm hoping that whenever I multiply this out, that this will equal this. So I go through, I start doing my multiplication, my distributing. So 1 minus sine squared of x minus sine squared of x plus sine to the fourth x okay, there we go. So again, the only point of that one is I just wanted to show you that you can work with either side. You're not doomed to always work with the left-hand side. If you see a way you can work with the right-hand side and make it work, go for it. Sometimes you work with both sides. You work with the left-hand side, you simplify it, and then you're like, okay, well, I don't know what else I can do with the left-hand side, so let me go over to the right-hand side and try simplifying that and see if I can turn it into the left-hand side now. No homework. Oh, you're going to have lots of homework. Practice, practice, practice with these as the best way to learn them. So again, quiz will have this just because I think it's easier for you to know what you're supposed to be equal to whenever you're doing your simplifying. Whereas if I just tell you simplifying Some of you are really getting lost with your simplifying because you go around in circles.